In section 4.6, we're using congruent triangles and talking about something shortcutted as CPCTC. This stands for. Nice long phrase that we're going to talk about here. So we've been proving triangles congruent, but what we've been missing is that we can go further from that, and once we know that triangles are congruent, we can gather extra information. Because we already know something about congruent figures. What is it that we already know about congruent figures? Or if I told you these figures are congruent, what would you know? Well, isn't it true that if you have two figures that are congruent, that all of their corresponding sides are congruent and all of their corresponding angles are congruent? So, what do I know about congruent figures? All corresponding. Remember, the word corresponding is important because we have to make sure that things match up in a sense. But we know that all corresponding sides and angles are congruent. That's what we know about congruent figures. And at this point, what are those shortcuts that we have for proving that triangles are congruent? Because I have ways to prove that triangles are congruent figures, and I have 4 shortcuts. Hopefully you remember them all. We had side, side, side. We had side, angle, side, with the included angle between two sides being congruent in two triangles. We had angle, side, angle, where the side is included between the two angles. And we had angle, angle, side. Or we could write that as side, angle, angle. These shortcuts all work. They prove triangles are congruent. But remember that if those triangles are congruent, it actually means that all of the corresponding sides and angles are congruent, not just the ones that you used to help prove the triangle's congruent. What I just said, if the triangles are congruent by one of these shortcuts, then really we know all of the corresponding sides and angles are congruent. This leads us to this CPCTC. I'm giving you this abbreviation that you can use in a proof because what this actually stands for is corresponding parts of congruent triangles are congruent. There's your CPCTC. Basically, once you have triangles that are congruent, you know all of the corresponding parts of those congruent triangles have to be congruent. Whatever you use to prove the triangle is congruent, whatever shortcut, all the corresponding sides and angles are now congruent. So why is CPCTC helpful? Why is it helpful that the corresponding parts of congruent triangles are congruent? Because, quick example here and just a summary of why we're using this. My question is, why is angle A congruent to angle C? Here's A and C, and why would those angles be congruent? Well, if I could show the triangles are congruent, the actual triangles, by a shortcut, then wouldn't I know that all of their corresponding parts are congruent? So, is there a way to show the triangles congruent? Are the triangles congruent? You notice we have 2 pairs of sides more congruent. Well, what about the side BD it's shared? So that's obviously congruent to itself. Now, do you see the shortcut that would prove these triangles are congruent? Hopefully you're thinking, yes, side, side, side. All 3 pairs of sides are congruent, therefore the triangles are congruent. So, really if you think about it, if these triangles are congruent, yeah, all their sides were congruent. That's what helped me show that they're congruent, but aren't all the angles that correspond now congruent as well? That's what would allow me to say all the corresponding angles are congruent too, since the triangles are congruent. Oops, corresponding angles are congruent too. So, yes, angle A is congruent to angle C because these are some corresponding angles here. Okay, so today is all about still like showing the triangles are congruent by a shortcut, but then going one step further and saying, well, now some of the corresponding angles or possibly corresponding sides that weren't part of me proving it are also congruent because all of their corresponding parts have to be once the figures are congruent. Let's do some practice with this. This one we're going to do a flowchart proof. Here's what I'm given is that GK, this line segment, bisects angle FGH. FGH. Angle FGH is this entire thing. Oh, and it bisects angle FKH. FKH is this entire angle. Interesting. I know that GK bisects both of those angles. And ultimately I'm trying to prove that line or side FK is congruent to HK. FK and HK are congruent. Well, I definitely don't know that. It's not marked, but I could prove that these two sides are congruent if these triangles are congruent by CP/CTC. Because if we have congruent triangles, then all the corresponding parts of those congruent triangles are also congruent. So your first, your first big step is proving the triangles are congruent. Let's get started on that. I need to write my given. I was given that line segment GK bisects two angles in this picture. Angle FGH, which I highlighted there, and angle FKH. Well, what does it mean to bisect an angle? Well, I know bisecting means cutting something in half or into two congruent parts. So we're going to have two congruent angles based on bisecting angle FGH. These two angles will be congruent. And I'll have to list those. Also, I'm going to have these two angles congruent because I bisected angle FKH. So I'll have to list these angles congruent as well. Actually, so there'll be two arrows going off of this and two new statements. Oh, you know what? I forgot something really important. The reason has to go underneath this. How did I know these things? It was because it was given. Sorry about that. Alright. Because that GK bisected angle FGH, I know that angle FGK and angle HGK are congruent. Those were the ones I marked with one arc. Angle FGK, angle HGK. Again, those were the ones I marked with one arc. How do I know that? Well, it's because of this word bisect. And so that's definition of bisect. Or definition of angle bisector in this case. And I'm going to have another kind of a similar statement here because I also bisected angle FKH, which is here, so now angle FKG. I wish I could write my letters correctly, sorry. Okay, congruent to angle HKG. Those are the ones I marked with. Wow, I am really sorry. HKG. And again, this is the definition of bisects. I know that those angles are congruent because I was told that this segment bisected the angles. Alright, at this point I have two angles marked congruent. There's got to be something else that would let me to say these triangles themselves are congruent. And actually, there is something that's shared between both triangles, isn't there? What's shared? Well, how about this side right here? KG is in both triangles. Therefore, it's congruent to itself. What property says that anything is congruent to itself? And you're thinking that's reflexive property. Property of congruency here. And there's no arrow here because this was something totally separate. But now, the fact that I have two angles and a side, all of these together should help me to say that the triangles are congruent. So now I gotta list what triangles are congruent. Make sure I create an okay congruent statement. So if I call this triangle, how about triangle KFG, is congruent to triangle. Now if I do KFG, I gotta correspond here, so KHG would be the corresponding vertices for the other triangle. What's the reason? What shortcut led me to this? Well, I have angle, side, angle. I noticed the side is in between the two congruent angles, so this is an angle, side, angle situation, the included side between the two congruent angles. Oh, but remember, we're going one step further today. I proved the triangle's congruent, so now I can say what they wanted me to prove. Now FK and HK have to be congruent, because guess what? They're corresponding sides in these triangles that I know are congruent at this point. So I go one step further and say, well, now that those triangles are congruent, I know that any corresponding parts are congruent too. So yes, FK and HK would have to be congruent because they are corresponding parts in congruent triangles, so they are congruent. CP/CTC. So you realize it's really only going one step further than what we did in the previous day or two proving that the triangles are congruent. Let's try another cool example here. We're writing a 2-column proof in this case. I'll set up the 2-column proof right away with my statements and reasons. Alright, I'm given that P is the midpoint of line segment RN. P is the midpoint of line segment RN. What does it mean to be the midpoint? It means it's in the middle. It means it cuts that segment into 2 congruent segments. It bisects. They kind of go hand in hand there. So when I start out with my given, P is the midpoint of Rn, you should already be thinking that I have some congruent segments because of this statement. This is given. What does that mean? If P is the midpoint of Rn, we have 2 congruent segments, P is the middle. So then segment RP would have to be congruent to segment PN, because again, midpoint means it's in the middle, you have 2 congruent segments from there. So I'm going to list those. I know that segment RP is congruent to segment NP. How do I know? From the word midpoint, therefore must be the definition of midpoint to have 2 congruent segments. Awesome, I have 1 pair of sides congruent. Now, I know ultimately I'm going to have to prove these triangles congruent because look, I'm trying to prove that side RS is congruent to MN. RS and MN. Well, those sides aren't marked. The only way I'm going to be able to show they're congruent is if I can show that these 2 triangles are congruent. And if they are, then those are corresponding sides, so then they'd have to be congruent. So I have to use one of my triangle shortcuts to show that they're congruent, so I better have more info. Actually, if you notice, I was given something else in the diagram. That angle S and angle M are right angles. That's what I'm given. Angle S and angle M are right angles. And I'm hoping all of this will help me prove that these triangles are congruent. This is also given, but I'm going to put in parentheses in the diagram because they were marked and not really stated up here. Well, what does that mean? If you know angle S and angle M are right angles, don't we know that all right angles are congruent? So angle S is congruent to angle M because they're both right angles. And right angles are congruent by right angles congruence there. Okay. There's got to be something else. We got a pair of sides. Got a pair of angles. What else do we see? There's got to be something in the picture that's congruent, and maybe you looked at these angles here. What kind of angles do we have here at vertex P? And you should be thinking these are vertical angles. And I know that vertical angles are congruent. So in my next step, I'm going to list these. Angle MPN, I have to use 3 letters there, I can't just say angle P, is congruent to MPN, I would have to say angle SPR. Reason why? Because those are what types of angles? They are vertical angles. And technically it's, again, vertical angles congruence theorem, like right angles congruence theorem, but I'm fine just saying vertical angles. We know vertical angles are congruent. Hey, now can I say that the triangles are congruent so that their parts are congruent? Well, yeah, I think the triangles are congruent by angle, angle, side, right? Angle, angle, side. The side is not between the angles. So I know that they're going to be congruent by angle, angle, side. You can also write that side, angle, angle. I have to list those triangles correctly. So if I name the first triangle MPN is congruent to triangle. Now I went from right angle to this middle vertex P out to N. So I have to go from right angle, middle vertex out there. So SPR happens to be just how I name those. And those triangles were congruent by angle, angle, side. So finally, I was trying to prove that some corresponding sides were congruent. Well, yeah, side RS has to be congruent then to side MN because these are corresponding sides in some congruent triangles, so those corresponding parts of those congruent triangles are congruent. CPCTC. So super fun proof there using CPCTC. And I got one more example that really challenges you a little bit. We're going to write a paragraph proof here. And look what we're ultimately trying to prove. We're trying to prove that triangle BCE is congruent to triangle DCE. Let's take a look here. Triangle BCE. BCE congruent to triangle DCE. Those are the two triangles I'm trying to prove are congruent. Let's see if I have enough info. I have these angles in the triangles congruent. I definitely know that this side is shared in those two triangles. Do I have anything else? There's nothing else I know about these triangles right now, so I really can't do anything yet. How in the world am I going to get another piece of info about these triangles? I need another side congruent or I need another angle congruent. We'll take a step back, and obviously there's more to this picture. Are there two other triangles in this picture that you could say are congruent? Then maybe we could use CPCTC to identify some more congruent parts, maybe some parts in these triangles. Now I'm going to get rid of that tick mark. But I'm hoping that you took a look and said, well, maybe I can use these larger triangles here. What if I use triangle CBA and triangle CDA? Well, if I use those, I think those triangles are congruent based on what I'm given. Those blue triangles are congruent because we have one angle pair, two angle pairs, and what's shared between these two blue triangles? How about this side right here, all the way CA? These triangles are congruent by angle, side, angle, right? So if these blue triangles are congruent, are there some parts of the blue triangles that are also part of the yellow triangles that I'm trying to prove congruent? Well, how about side BC and CD? Those are part of the blue triangles and the yellow triangles, so once the blue triangles are congruent, I can say those sides are congruent by CPCTC, and then we can help explain why the yellow triangles are congruent. Wow, okay, lots to do. I got to start out and say what I was given, and I got to prove these blue triangles congruent first. So I'm going to say I am given in the diagram, or in the picture, that angle 1 was congruent to angle 2. Those are marked. And angle 3 is congruent to angle 4. Angle 4 because they were marked. Okay, what else helped us with those blue triangles? We had the two angles, but then we had to say that this side was shared, right? So that side CA, since it was shared, is congruent to itself by reflexive property. We know anything's congruent to itself. So I can say those blue triangles are congruent. Triangle CDA is congruent to triangle, let's see, if I do CDA, I'm going to have to correspond by saying CBA. By what shortcut here? I know I had two angles and a side pair, and it was angle, then the side, then the angle, right? Angle, side, angle. Now, why did I do all that? I proved that the blue triangles were congruent so that I could find a corresponding part that is congruent, but also in the yellow triangle. And those parts would be these sides, because this is part of the yellow and the blue triangle, these sides. So I'm going to list those and say now I know that side BC is congruent to side DC, or CD, sorry, BC and CD, because of CPCTC. Corresponding parts of those congruent blue triangles are congruent. Now, for those yellow triangles, I'm going to get rid of the blue triangles for a second because I don't need them. I'm now looking at the yellow triangles, and we know that BC is congruent to CD. Put two tick marks there. You know what? I'm also going to get rid of this because we're not talking about the blue triangles anymore. We're talking about the yellow triangles. So for the yellow triangles, using angles 1 and 2 congruent, those are part of the yellow triangles. Using BC and CD congruent, those are part of the yellow triangles. And one more thing. What else was shared between the yellow triangles that could help prove them congruent? How about that side CE right there? CE is congruent to itself. By what property? Reflexive again. There's another side. So we have 3 pieces of info to finally prove that these triangles are congruent. Because I have 3 pieces of info, it should be a valid shortcut. Triangle BC is congruent to triangle DCE by what shortcut? I notice I have 2 sides congruent and an angle. 2 sides congruent and an angle. The angle is between the sides, so side, angle, side. Whew. So I had to use congruent triangles here, and then use CPCTC to find some more parts of those triangles that were also in the little triangles I wanted to prove congruent, and use another shortcut to prove those triangles were congruent. So CPCTC, remember, stands for corresponding parts of congruent triangles are congruent. I'm going to quiz you on that tomorrow. But it's going one step further. You prove triangles are congruent, and then you use CPCTC to say any of their corresponding parts have to be congruent.